Okay, so now you're probably at the point in the course where you're asked to do some long division. So kind of a throwback to elementary school here when you had to do long division with integers. This time, I mean, the process is very similar, except we're dealing with polynomials instead of actual just straight up integers. But again, the algorithm and the steps is actually oddly similar. So we're going to do an example here, and actually after this example we're going to do the exact same polynomial divided by a binomial using synthetic division. So there's going to be two ways that we can go about completing long division of polynomials, and it's the long division, which we're going to do first, followed by the synthetic division. Two different ways to get to the same answer. They both have their relevant applications. Long division actually will come in handy in the next unit when we're looking at rational functions. There is an element where that skill might be important. I do prefer the synthetic division method that we're going to do after this problem, just primarily because the synthetic division is actually the exact same thing as polynomial long division. It just actually it streamlines it, takes all the variables out of it, and you're just dealing with the numbers. But again, like, there is some overlap, and you're going to see there's some like numbers that pop up that are similar between the steps. Again, two different methods to get the same conclusion, both valid, and I would never ask if you are factoring a polynomial to do one method over another. So to start here, we're gonna do some polynomial long division. So what we have here is this polynomial. We'll call that p of x, and we're going to divide that by x plus 3. Now, you have to be observant here. If you look at this polynomial, you're going to see that there's a missing x to the cubed term. So when we're doing polynomial long division, just put a placeholder in of 0x cubed. I'm just going to write this out. Okay, so just put that placeholder in. Now, let's start here. So with the polynomial long division, we're going to write out that polynomial. Plus 0x cubed Okay, now that we're done writing that out, we're going to divide that thing. Let's make that a little bit nicer. We're going to divide that by x plus 3. So we're going to go through the steps here. So follow closely. Now, I will say this is a skill that you're just going to need some reps. You're going to need practice. That's really the only way to get good at it. Okay, so the first step. We want to take this x term. What do we have to multiply this x term to get to 3x to the 4? So to multiply that by some number to get to 3x to the 4, and that number will be 3x squared. 3x squared times x, 3x cubed, my apologies, 3x cubed times x will give me 3x to the 4. So the next step now is to distribute that 3x cubed to both of these terms here and there. So we would simply just say, okay, 3x cubed times x is 3x to the 4, and then 3x cubed times 3 is plus 9x cubed. All right, so we're going to draw a line there. Now the goal when you're working through this, I'm going to clean this 3 up here. There we go. The goal when you're working through this is you want your leading term to 0 out. So we're going to do some subtraction. So 3x to the 4 minus 3x to the 4 is 0. And then 0x cubed minus 9x cubed is minus 9x cubed. Okay, the next step. We're going to bring down this negative 2x squared. And then we want to think similar to the first step. What do we have to multiply this x by to get to negative 9x cubed? So So we have to multiply that x by negative 9x squared. Negative 9x squared times x will give us negative 9x cubed. So now we're going to distribute that negative 9x squared to those terms of that binomial. So that's going to give us negative 9x cubed, and then negative 9x squared times 3 is negative 27x squared. All right, so now we're going to do the same thing. We're going to do some subtraction. I'm just going to extend the line a little bit more. So when we're dealing with these negatives here, this is where I do see errors pop up. Remember, if you subtract a negative, you're adding. So we're going to go negative 9x cubed minus negative 9x cubed. That's essentially adding, so that's going to zero out. And then we're going to have negative 2x squared minus negative 27x squared, or that's the same thing as adding 27x squared. So negative 2 plus 27 is positive 25x squared. Then we're going to bring this term down. And we're going to repeat the process. What do we need to multiply this x by to get to 25x squared? Well, we just need to multiply that by 25x. And then we're going to distribute that 25x to both terms of that binomial. So 25x times x is 25x squared. And then 25x times 3 is 75x. We're going to do the subtraction, and we're almost there. So 25x squared minus 25x squared. Again, the goal is to zero out that leading term. And then we're going to go 15x minus 75x. That's going to be negative 60x. We're going to bring down that last term, that negative 10. And finally, what do we need to multiply x by to get to negative 60x? We just need to multiply x by negative 60. And that's going to give us, if we distribute that, negative 60x, and then negative 60 times 3 is negative 180. So let's take the difference there. That's negative 60x plus 60x, which is 0. And then we're going to have negative 10 plus 180, which is positive 170. Okay. This guy right here is your remainder. So what does this all mean? So basically, we have our polynomial at x. Let's call this our polynomial at x. We really didn't define it. So basically, this polynomial at x is equal to x plus 3, which is our divisor, times our quotient, which is 3x cubed minus 9x squared plus 25x minus 60. So those two things multiply to your polynomial, but then we have this remainder of 170 at the end. It should be all on one line there. Actually, let's redraw that. So it should be, and then plus that remainder of 170. Okay. So another way that you might see this written is your polynomial at x divided by x plus 3, which is what we did. We took our polynomial and we divided it by x plus 3. And that's going to be equal to 3x cubed minus 9x squared plus 25x minus 60 plus 170 over x plus 3. We just divided everything by x plus 3. One way you might see it written as well. And just to identify what each of these components are, this is your divisor. This is your quotient. And this is your remainder. Okay, so how can we do some similar stuff when we could use synthetic division? So we're going to jump down to question 10 here. I just want to acknowledge, there was a lot of steps here. It's very algorithmic, so again, you need to do some reps and do some practice to get the hang of this. Okay, let's use synthetic division. We're going to jump down to question 10. Okay. So this one says use synthetic division. What we're going to do is divide this guy, this polynomial here, which is I think the same polynomial as above. We'll call it p of x by x plus 3. So the strategy with synthetic division, again, I want to acknowledge that there's a missing term here. So we're just going to put a placeholder of 0x cubed. Okay. All right, so how do we synthetic divide? Well, we're going to set up a table. It looks something like this. And what we're going to do is we're only going to use the coefficients of our polynomial. So it'll be 3, 0, -2, 15, and -10. Okay? And now keep in mind, we're dividing it by x plus 3. So I'm going to take that plus 3 from that binomial and put it there. And then I'm going to put a subtraction symbol right there. So here's the steps. The first step is to bring down this 3. The next step is you take this number here, 3, and you're going to multiply it by that number. So 3 times 3 is positive 9, and that's going to go right here. Then you're going to go 0 minus 9, which is going to be -9. And then you're going to do it all over again. You're going to go -9 times 3, which is -27. You're going to go -2. Sorry. You're going to go -2, subtract -27. So that's going to be adding 27, so that's going to be positive 25. You're going to go 25 times 3, which is 75. You're going to go 15 minus 75, which is -60. Then you're going to go -60 times 3, which is -180. It's going to make it a little bit bigger. Then you're going to go -10 plus 180, which is 170. This last term is your remainder. Now, this looks oddly similar, I think, to the last one. So what does this all mean? What do these numbers mean? Well, these are valuable, these coefficients here. So I'm going to write them out again. So that's going to be 3, -9, 25, and -60. Well, they're going to be attached to variables. Now, take a look here. This was a 4th degree polynomial. Well, the quotient that you just came up with in synthetic division is going to be 1 degree less. So it'll be x3, x2, x1, and then that last one's your constant. So this is what we came up with. And then it has a remainder of 170. Just to kind of reiterate what this all means, it means our polynomial at x is equal to, so we can say it's equal to x plus 3 times that quotient, which was 3x cubed minus 9x squared. Well, this should be plus 25x minus 60. And then there is a remainder of 170. So that's what that all means. The alternative way you might see this written is your polynomial at x divided by x plus 3, which is what we did in that synthetic division process, is equal to, this guy here is your quotient. It's usually referred to as the quotient at x. But this is going to be equal to your quotient, so 3x squared cubed, minus 9x squared plus 25x minus 60 plus 170 over x plus 3. So a couple ways you might see this written. So those are some steps here on how to synthetic divide and long division. This is going to come in handy in the next activities when we are asked to fully factor some larger polynomials.